have to be a factory tool, but it holds the shank while the collar is actually spun and it finally breaks away.
You said you didn't want the 3 threads showing?
There's a general guideline for if you selected the correct grip. You should have maybe about 2 threads showing on the collar after the wrenching flats break away. If you don't have enough thread, it means that you got too short of a pin. If you got more than that, the pin is too long.
Do you need to replace them if that happens, or
You selected the wrong one. Cessna came out with a little video too that's kind of interesting. What about if you have to get a high lock in position where it's kind of a restricted area? You have to push it through a structure in order to get to the point where it gets to the hole. How do you do that? What they do is kind of an interesting thing. Let me show you this.
Hi, I'm Dennis Kellerman with the Cessna Structures Group. On a weekly basis, at least, or possibly a daily basis, we receive questions on, can I use a pull fastener in a particular area, and that area is normally associated with the backside of the horizontal stabilizer where the elevator attach points are, as well as attach points on the elevator itself, or it could also be on the vertical stabilizer spar for the rudder attach points. Well, our policy is that we don't use pull fasteners in these areas. They just don't have the integrity that we want that is associated with flight control. So we cannot use the substitutions that often people are asking for. So what we normally call out, and this is a case-by-case approval, is that we call out the use of a fastener. Well, the question comes, how am I going to possibly get a high-lock fastener in an area that has limited or no access? Well, today I'd like to talk about a technique that we tell people to use, and it seems to be working really good in the field, and that is taking the high-lock fastener and using regular string trimmer line. The internal wrenching bore that is used to secure, to hold the high-lock fastener during installation is 5/32 in size. And it happens to be that the line that I have here today is 80,000 string trimmer that is a pattern of it's 5-sided, so it's kind of like shaped like a pentagon. And this is a perfect fit, slides in, and you can see just by the amount of tension I put it on this that it really holds well. If you don't think that's secure enough, and I understand why you wouldn't want to lose a fastener in the back of a horizontal stabilizer or something like that, you can simply put on a little bit of super glue before you install the string and then dig that out later. Well, it's quite simple, and it's a real time saver. And in fact, another little tip along with this is if you feel that the string technique is just too flimsy, it's kind of like pushing a noodle, you might want to go ahead and attach some heavy safety wire to do the fishing as you go through a small hole, or even bringing some of the skin back just a little bit, or just a fastener or two to get it in place. Push that in there along with safety wire, and then you can pull the safety wire off once you get it through the hole. Once the high-lock pin is through the hole, because of the close tolerance fit you have, you probably want to use a free-running nut once you grab the threads to pull the fastener through for final installation. Thank you. I hope this has been helpful for you. If you have any questions involving the structure of your Cessna aircraft, give us a call at 31.
Okay, so a few tricks of the trade anyway. If you got a restricted area, sometimes you can use some string trimmer line in order to attach to the end of the recess where the mount would go. Also, too, since it's an interference fit hole, as soon as the fastener starts through the hole, you probably wouldn't want to put the collar on then, because the collar, the wrenching flats would really break off. So in order to get the rest of the fastener through and flush with the material, you just take a regular nut, thread it in position, tighten that down, FAA wants you to know standard hand tools for installation, but again, for factory tools too. Some of the factory tools are modified wrenches where they've taken out the push button release feature on a ratchet wrench, and it gives you a hole that you can put the Allen head through in order to get to the collar side. So that's all that they do. For removing them, it's easy to remove. All you have to do is hold onto the collar using an Allen wrench, or hold onto the pin with an Allen wrench. You can then spin or just unthread the collar with a pair of pliers. Pretty simple to do. You're going to have to replace them anyway, so there's nothing that's going to be salvaged during replacement. You're going to have to use a new pin and a new collar for installation. So that's how they kind of come out. There's also this is important as well. The holes are all interference fit holes. This is just one example. I'll never ask you specific amount of tolerance. But for the case, for example, for a 5/32 inch diameter fastener, the hole is undersized. The hole varies in size anywhere from 1/625 to 1/645. And again, you're going to have to tap the fastener in order to get it properly set. If you don't have this type of interference fit, you're going to have very poor carry-through strength in the structure. So again, it's usually an interference fit hole. High Shear came up with this variety of special fasteners called a high T. You still have to drill a hole that's somewhat undersized, but it gives you a bold angle or a bold type of shank on the fastener that will provide for better carry-through strength than the standard versions of the fastener. So the hole is usually, it gives you an interference fit that's equivalent to about 2 to 4 thousandths when it's installed. But it's an exaggerated view to show you kind of pull this section of the shank. But on some structure, it's important to have that. Sometimes maybe where they can't get a precision drill hole, we'll use a high T version of that particular fastener. And there's a picture of the lock or the grip gauges used for these. Again, every particular variety of special fastener has its own kind of unique grip gauge. This one is dedicated specifically to high locks. That's what they're used for. Something else too, you occasionally see these things used in the field. These are kind of like go, no-go gauges for these fasteners. It's a step-type gauge, and what you do is you put them over an installed lock or an installed high lock, and provided it fits within the range that you have between the two steps, generally you've got a correct installation. But they're step gauges, they're protrusion gauges. They come on a key ring. I've got a sample someplace in my toolbox, but again, gives you an idea of how they're installed. This is what they would look like after installation. And again, generally speaking, if I had to give you some guidance and information on installation, you're looking for about 2 threads of projection beyond the collar. That'll ensure that you've got enough engagement of the pin through the collar itself. If you don't have that, you probably selected the wrong pin limit. Removal, pretty simple. You grab onto the end of the pin, and then you spin the collar off with a pair of pliers. Okay. That's it. Okay. One more special fastener. This is called a Joe bolt. Joe bolts are blind, but they have the strength of generally of bolts. So it's kind of a fastener that's like a bolt, but not necessarily. It's blind, I should tell you that. The way that it's installed, I think the installation of one for the animation will kind of tell you a lot about it. But they're used by Beechcraft quite frequently for assembly of landing gear. Let me kind of show you what they look like. So you've got a pulling mandrel or a pulling head that grabs on the top of it. You can see what it does is it spins the mandrel. That top portion of the fastener works kind of like a nut. What it does is it draws down or bears against the fastener. Then at a certain point, the head of the fastener kind of comes free. That's called a Joe bolt. It's an internally threaded 3-piece type of fastener. So that's what it looks like before and after installation. As you might guess, you're going to have special drills in order to install them. And it's usually a multi-step process. You have to pilot drill first, and then you have to resize the hole in order to get the correct hole. But again, for landing gear connection, a lot of Beechcraft aircraft, that's common for that. There's also a composite version of that type of fastener. The big difference is the end of the fastener that bears against the composite composite structure is subject to delamination because it's made of fibrous, the composite materials are made of fibrous material. So in order to avoid delamination, what they've done is they've designed a fastener with a big footprint on the end of it, so that when you cinch up on the jaw bolt itself, the big diameter that you have of the collar side of it, it prevents delamination of the material. So anyway, that's the only big difference for it. So again, just a particular variety of jaw bolts that might be used for installation. And for removal, they usually have, again, multi-step operation for removal of the fastener. You're going to have to pilot size, and then you're going to have to resize in order to get the thing out, in order not to enlarge the hole. Is it about time for a break? What time is it? 9 o'clock. Why don't we take a break for 1/2 hour?